I'd like to invite everybody who spoke in that session to turn on their video if they're comfortable with it, and we will tackle questions one by one. And so my first question is for Noah. Noah, some of this was addressed in the chat, but I just wanted to offer you the opportunity to address it as well. Does the Artemis 3 science plan include orbiting imaging spectrometers? Anything else you want to say about that?
Yeah, right now, no, we don't have plans for an orbiting imaging spectrometer. There's certainly, additional hardware to the moon is always ideal. But I also think we got to ask the question, what's realistic for putting on instrumentation, adding a spectrometer to an Orion capsule or a dedicated lunar orbiting mission? I would rather see it on a dedicated, stable platform that whose main objective is to map the moon rather than on an Orion spacecraft. Apollo did carry along rudimentary spectrometers if there's an opportunity for something, but I think we'd all want a more dedicated observing strategy for a spectrometer than adding it on to an already oversubscribed mission in an orbit that may not be ideal for orbiting spectroscopy.
Thanks, Noah. Okay, the next question I'll direct at Dr. Elbaz. I see you're still with us. So Dr. Elbaz, was there anything on Apollo that you wanted to see done in terms of orbital observations that you didn't do? So just looking for recommendations for us for Artemis.
Indeed, indeed, there are certain things. We needed more time in the flight plan for observation, and we needed additional time in orbit. But the powers to be thought that the time that we have is plenty, and that's enough. Keep the mission to the absolute minimum because of the safety of the astronauts and all kinds of things that would not be assured if we extended the time.
Thank you. Super insightful. Okay, to Dave. There was a lot of chatter about this in the chat, but just want to give you an opportunity to address it out loud. Is there anything else you want to say about the question of radiometrically, geometrically calibrating the D5s? Anything else you want to contribute about that topic?
Yeah, unfortunately, it's a D5, just like we flew on station. So radiometric calibrating a DSLR, it's a high-end DSLR, so you can tweak the color temperature. You could put it in front of a target, but in order to do that, what we really need is somebody to stand up and say there's a requirement for it. Right now, unfortunately, this is the politics of program stuff. Everything needs to be funded, and in order to fund it, you have to have a requirement for it. So if the science team really wants to truly calibrate these cameras, we can discuss that. I'm not saying no, we can discuss it, but in order to pull that off, there would be some sort of a certification campaign, which means the testing has to be funded, and there probably has to be a requirement written down somewhere. So I'm willing to support that, but as of right now, there is no requirement for that.
Thanks, appreciate it. Okay, I will ask Sarah the next question. Sarah, you gave us a lot of experience, obviously, from International Space Station. We'll have a lot less time in lunar orbit than ISS crews often have. Do you have any recommendations for us, given the reality of lunar time in orbit, especially given what we just heard from Dr. Elbaz, that more time is always better? Any thoughts there? Why are you still here, Sarah? I should have checked that before.
Sorry, I was muted.
On the spot. Okay.
Kent is our civil on this, our NASA lead, so he might have some information to provide as well. But I would say our ample planning and live mission ops is going to be huge factors into the short time period. We know how long the time period of the flyby is going to be and how long the mission is. So just minute by minute planning if we can, and doing everything we can to prepare for anything that may happen.
Plan. That's what we heard from Kent as well.
Exactly.
Kent, do you want to add anything to that, Kent?
Yeah, I would say Sarah had a good answer there. We've done similar activities, like she said, when she showed the example of Jessica Watkins, and actually we work with Axiom Private Crew where we do these dedicated 3 hours increments and have tested how quickly we can get crew to go from a target to a target to a target in a short period of time and still get good imagery. So I think we can get a plan together that'll work really well for this.
And if I could build on that too, to your point, practice, also sim it as well for both the flight control team and the crew. So Thanks for that. Okay, back to Noah. From Probable, in addition to Earthrise, there may be really valuable images taken from orbit of the Earth for both Earth science and exoplanet perspectives. Is there an Earth science or GOES system liaison that can offer support on the types of images that may be high value depending on the launch date and observations? These observations may be useful targets when lunar observations aren't always possible.
That's a great question, and thanks for asking that, Probable. You know, at this point, to work through that, well, first of all, you know, I would say even if there are high value, useful targets for the moon, that we should come up with a plan that allows for the acquisition of these images. Right now, there are no GOES system liaisons, and you know we do have some inroads with Earth Science for Artemis support. But I would say if you or anyone else has ideas, suggestions, hey, when the Earth is X phase, I know that there are still outstanding questions about Earth color from significant distances. And of course, we're going to have astronauts at significant distances, the first time to deep space in over 50 years. So I would like to ask you, Probable, to start putting together those thoughts and send that to Kelsey and I. Kelsey is the imaging lead for Artemis 2. Certainly, you know, again, we use Artemis 2 to test and prove what we can do on subsequent missions. And there's no greater chance that we have than now to do that. Artemis 2 is going to have multiple high orbits around the Earth before going to or a high orbit over the Earth before going to the moon. So we may have multiple opportunities. We do have, Kelsey, correct me if I'm wrong, from what you said an hour plus ago, you know, several imaging windows beyond just the lunar pass that we could potentially use. So coming up with the criteria for that, the constraints for that probably would be very valuable. And I would open that up to anybody else who says, hey, when the moon is X, try Y. Now's the time to be doing that.
Wow, that was just brilliant. Probable. Did you hear that? You ask a question and get an action. I love it. I'm taking notes on Noah's strategy. No, that's a great answer. And this is also the type of stuff to talk about in the breakout. So definitely encourage more deeper dives on this in the breakouts. Okay, back to Dr. Elbaz. Did you ever feel that the crew ever felt overwhelmed by imaging tasks, you know, given the tight choreography that we know we're going to need from them? Any lessons learned to share from Apollo on how you guys handled that choreography?
Not at all. Actually, it was the reverse. Most of the crews came down and said, I wish I had more time to do X and X and X and X. Because they really enjoyed being able to see and interpret and convey their interpretation as they see it.
Amazing. That's amazing feedback.
We certainly encourage that because we learned a great deal from them about the color, the texture, the relationships between things, and the way we should be looking at the photographs, because we have no idea what the color for the black and white photographs could actually tell us, but how far off are they? And we certainly realized later that they are far off reality. So whatever the astronauts conveyed to us was something new. And whenever they said something that about the features of such and such, that made us look at it and realize something new. So the human eye can pick up a great deal more than any sensor up till now that I know of can do. The variations in the color and the texture differences between materials and the lunar surface were picked up by the crews visually a lot more than we could actually record by film, no matter how sensitive the film we used.
That's amazing. Thank you so much. I'm glad this is being recorded because I need to go in and take out that answer for Noah and I to justify what we're asking for on some of these missions. So thank you very much. Okay. Dave, back to you. Anything else you want to say about imaging spectrometers? I know you talked in the chat, just wanted to give you another opportunity to address that question.
I would love to see an imaging spectrometer fly on the vehicle. The problem is finding a mounting position on the vehicle. We really don't have a viable external mounting location on Orion to put that kind of a telescope. I would love to see one, but even if we found a place to put one, obviously it has to be funded. You know, that's kind of the bottom line always. And mass on the spacecraft is a very, very big problem right now. Just on Artemis 2, we're close to being overweight. So one could ask, well, if you're overweight on Artemis 2, how on earth are you going to fly the bigger missions later? We don't know. So as of right now, weight is a serious challenge.
Thanks. Okay, I think Dave addressed a lot of the questions that came in subsequently for him. Thanks, Dave, for being on it on the chat. But I'll go to one other one. I think, well, I'll turn this one to Noah, actually, I think. Noah, imaging is not just about taking pictures. It includes access to those pictures. As we move through the program, we'll need a dedicated image access and distribution system, searchable database of orbital and surface images. Do they go into PDS? Is this a new system? Dave addressed the point of where they go on the NASA end, but in terms of making them publicly available, Noah is our Artemis data lead. So Noah, any thoughts?
Yeah, that's a great question. And we're starting to work with, not just starting, we are working with the PDS on how to basically do that. We want to make sure that whatever is archived on, as Dave pointed out, we have the imagery online at JSC. We want to be able to basically complement that so it becomes a one-stop shop for, hey, I want all lunar data collected by Artemis 2 or 3, which includes crew photography. And so getting that to the PDS is certainly something we want to do. As he mentioned as well, they're going to be the surface photographs that are taken by crew members, and those will be archived in the PDS as well as any special derived products that are generated by the geology team or the Artemis 3 science team. And so, yes, we're looking to get all of this ultimately in multiple places, but again, planetary data users are used to looking at the PDS for this material, and so making sure it's archived there is definitely a priority for the Artemis science team.
Yeah, and I'll add to that I think that's also pathfinding for us. The amount of data we're getting back from these missions is only going to increase as we move forward, and so I think it'll be important to demonstrate this capability for Artemis 2 as a proof of concept for the future, as well as being scientifically important in its own right.